Long ago, in the beginning, there was the atom, the building block of everything we see, know, and touch.
The atom was deemed as uncuttable according to the philosophers Democritus and Leucippus. However, as they were not scientists, their opinions were rejected by the scientific world.
The true beginning of the discovery of the atomic model started with John Dalton in 1809.
Actually, it was 1808.
John Dalton, what are you doing here?
I'm here to explain the true model of the atom. You see, matter consists of indivisible atoms. Atoms can arrange themselves in different combinations to make different compounds.
Oh, I see. That makes sense. Thanks, John.
No problem, this is my job. History continues with J.J. Thomson, who discovered one of the most important parts of the atom.
The electron.
J.J. Thomson?
Yeah, that's me. Heard you talking about me.
Yeah, I was just going to talk about the discovery of the electron. Wasn't there a model you used?
Plum pudding.
Plum pudding?
Yeah, the plum pudding model. You see, I imagine the atom looking like this. The dough is the positively charged part of the atom, while all the blueberries are the electrons.
Wow, this is an interesting concept on how the atom looks. But why did you call it plum pudding?
Because it looks like plum pudding.
Oh, okay. I guess that makes sense. Thanks, JJ.
Although these discoveries were groundbreaking, many were still skeptical about the idea of the atom.
The atom must exist!
Albert Einstein!
Yeah, that's me.
So how did you prove the atom existed?
Well, there was an experiment done with pollen grains suspended in water by Robert Brown. When observed through a microscope, the pollen would move oddly. I reasoned that pollen must be made of tiny particles, since the pollen could only move if it was moved by something else, which happened to be the atom.
That makes sense. Thanks, Einstein. The paper Einstein wrote about the pollen ended the debate. It changed how people viewed scientists who believed in atoms. Another breakthrough through atomic model history would be made by Ernest Rutherford. He came up with a nuclear model for the atom.
That's right.
Oh, hey, Ernest Rutherford.
Hi.
I was just talking about the nuclear model of the atom.
I discovered that all the positive charge of the atom is concentrated in the center of the atom, and all the negatively charged particles are distanced from the center and spread apart.
How did you find this out?
Well,
We observed alpha particles being fired at a piece of gold foil. We expected most of the particles to go right through the gold foil, since we thought the electrons were distributed evenly throughout the atom and the rest of the atom was positively charged.
Like the plum pudding model?
Yeah, that's right. We just thought the particles would pass right through, but occasionally some would bounce right back. We reasoned that there must be a large positively charged particle at the center of the atom.
So did you change how the model looked like?
yeah, it looks something like this. All the positive charge is concentrated in the center, and the atom is mostly empty space.
This model kind of looks similar to Niels Bohr's model. Did someone call me?
Hey, buddy!
Hey! Niels Bohr, we were just talking about your atomic model. Oh yeah, I thought that electrons orbit around the nucleus, kind of like how planets orbit around the sun. It looks something like this. Interesting. Hey, you also came up with the idea for quantum jumps, right? Yeah, I imagine atoms like buildings with multiple floors. Basically, electrons live in each of these floors and can jump from one floor to another. In other words, basically, electrons can jump from one energy level to another. Hey guys, forgot to talk about something super important to quantum theory. When the electrons jump down from one energy level to the next, the electrons have to release energy. They release energy through wavelengths of light, which we see as color. These electrons will emit different colors depending on how far these electrons drop in energy levels. Pretty cool. Whoa, that's pretty cool.
Quantum theory doesn't exist!
Yeah, you want to go?
Let's take this to the Solvay conference.
Fine then!
Wait, hey! Oh, wait for me! After much debating, Bohr eventually won the 1927 Solvay Conference debate, and he proved his stance on quantum theory. Around the same time, Erwin Schrödinger made the quantum mechanical model.
That's right. Let me explain what I mean.
Go for it.
Well, I imagine electrons to be more like flies buzzing around the atom instead of orbits.
Oh, so is it like Bohr's model?
No, the electrons buzz around the atom like this, and then they make different shapes and patterns as they go around.
Oh, I see. That explains electrons, but what about protons and neutrons? That's right. James Chadwick come in. You see, I discovered neutrons and protons in the middle of the atom. See, look at that. What a beauty. Oh, that makes sense. Thanks, guys.
Thanks to Democritus and Lysippus,
John Dalton,
J.J. Thomson,
Ernest Rutherford,
Niels Bohr,
Erwin Schrödinger,
and James Chadwick, we now know the history of the atomic model. Thanks for watching! My bad. Okay, should we do that again?
No.
Oh.